Hello everyone, welcome to all in this lecture. In this lecture, I am going to discuss few numerical problems from center of gravity. So before this, going to discuss numerical problem from the to calculate the center of gravity. So you can see these are the formula for the integration and differentiation. So you have to remember this formula. So whenever you will will require there is integration, you have to apply the integration for the calculation of center of gravity. So in this formula you can apply. Okay, so just write down and try to remember all these formula from the integration and differentiation. Okay, now the first question we have. So this x is this line, the curve of line is a y is equal to x square, and for this area that is O from O to, suppose this point is A and B, so we have to calculate center of gravity for the this area. Suppose center of gravity will be here. Okay, so we have to find what will be the y bar and what will be the x bar. Okay, we have to find x bar and y bar. Now how we can find? So to find the x bar and y bar, take a small segment. So I'm taking parallel to x-axis to calculate y bar. So I'm taking a segment somewhere here, and this segment is y distance from x-axis. So thickness of this segment will be dy, very small length in y direction. Then what will be the length? So what will be the length? This one. Okay, so total length we have from here to here. Total length is 2 meter. That is given 20. This coordinate is 2, 4. It means x is 2 and y is 4. So this is, and if this one is up to this point, I'm talking about up this point is, if this is y, so what will be the x? So see, we have the curve this one, y is equal x square, or we can write x is equal to root under y. So here y is y, this coordinate is y. So x we can write here. So x will be x is equal to root under y. So we can write directly this is the root under y. Now, so what will be this length? So what will be the length of this segment? So thickness is dy. So what will be the length? Total length we have from here to here 2 meter, and this from this point to initial point of this segment, so that is root under y. So we can write this length 2 minus root under y for this segment. Now we can calculate area of this small segment, that is we denote by dA. Okay, so we can write this is the rectangular section, so we can write area would be length into width. So we can write 2 minus root under y, that is length into width, that is dy. Are you getting my point? Okay, and lower limit, what will be the lower limit? So this segment suppose will be here, so here y will be 0, and suppose this segment will be here, so y will be 4. So here 4 is the upper limit and y is equal to 0 is the lower limit. Right, now we can write the formula: y by integration of y dash dA divided by integration of dA. Now, what will be the y dash? So y dash is the distance of centroid of segment from the x-axis. So for this segment, centroid will be somewhere here. So distance from the x-axis would be y. So we can write integration y at the place of y dash, we can write y. Now we can put the value of dA. So that will be the 2 minus root under root y into dy. Divide by integration. Here also you can put the value of, see, this we are not cancelling because the area is we don't know what this area. So area also we have to calculate. So by integration also we can calculate area. 2 minus root under root y dy. What will be the lower limit? 0, and what will be the upper limit? That is 4. 0 to 4. Now we can simplify. 2y minus y to the power 3 by 2 we can write. Two minus here also we can write y to the power half, or we can say 1 by 2. Now we can do the integration. See here, integration of y will be y square by 2. So 2 will cancel. Directly we can write y square minus here y to the power 3 by 2. So integration would be y to the power 5 by 2 divided by 5 by 2. Limit is 0 to 4. Now here this is 2 is constant. So integration of 2 will be with respect to y. So it will be 2y minus integration of y to the power half. It will be y to the power 3 by 2 divided by 3 by 2. In this integration method, I am using only one formula, that is integration of y with respect to integration of y to the power n with respect to y. It would be y to the power n plus 1 divided by n plus 1. So I am using this formula everywhere in this case. Now we can put the value 4 by putting the value 0. So this would be 4 square minus 0. So I'm directly 4 because everywhere is y. So by putting the 0, it will get minus y, minus 0. So something minus 0, it won't change. So I'm writing directly 4, put the value y is equal to 4. So 4 square minus 4 to the power 5 by 2 divided by 5 by 2. In the denominator, 2 into 4 minus 4 to the power 3 by 2 divided by 3 by 2. What we can write? 16 minus 32 into 2 divided by 5. Or we can write 8 minus 2 to the power 2. We will cancel. So it will be 8 into 2 divided by 3. So by solving, you can solve also. So by solving, we will get the value, that is 1.2 meter. So y bar we got 1.2 meter. In the integration, I only use this formula, that is integration of y to the power n with respect to y is equal to y to the power n plus 1 divided by n plus 1. And here also is constant we can write, but for the definite integral, no need to write constant. So I'm using this formula. Now we can calculate x bar. So to calculate x bar, take a segment parallel to y-axis. Taken this segment, and that is at a distance x from the y-axis, and their thickness for this segment is dx. Are you getting a point? So what will be this value? That is this will be y. For this we can write here the equation. This coordinate will be, what will be this coordinate? So this coordinate we can write x square. Okay, so y is equal to x square. So what is the segment we get? Length, we get x square. And what is this? This we get dx. So now a small area for this segment we can write x square, length into width, x square into dx. And what will be the lower limit? So once this segment will be here, so x will be 0. Once the segment will be here, so x will be 2. So this is the upper limit, and this is the lower limit. Now, formula we have x bar is equal to integration of x dash dA divided by integration of dA. Now, in this case, x dash, distance of centroid of segment from the y-axis, that is x in this figure. Because centroid will be here somewhere, so distance from the y-axis will be x. So we can write integration x. Now we can put the value of dA, that is x square dx, right? We don't know the area, so we will find out in the terms of integration. So I'm writing in place of dA, I'm writing x square dx. What is the limit? 0 to 2. 0 to 2. Now, by solving, we can write integration of 0 to 2 x cube dx divided by now. Again, I'm using the same formula which I have used in the previous slide. So we can write x to the power 4 divided by 4 divided by x cube x to the power 3 divided by 3. So what I'm getting? 16 divided by 4, 8 divided by 3. So by solving, you will get 6 by 4. We can write 3 by 2, or we can write 1.5 meter. That is x bar. Okay, so here also I have used one formula, that is integration of x to the power n with respect to it, that is x to the power n plus 1 divided by n plus 1. So this formula I have used here. This is constant, C is constant, but when you are putting the limit, lower limit, upper limit, so no need to write constant. Okay. Now, this is the next question we have. So this is the area, this is the rectangular area. And this it is two hole, that is one hole is made in this rectangular section, one hole is circular, and one hole is triangular. Okay, so we have to calculate the centroid or center of gravity for the remaining section. Okay, this is hole. Okay, and remaining part is this one. Remaining part is this one. Okay, so what is our main aim? To find out the x bar and y bar for the remaining figure, for the remaining figure. Okay, so how it will come? So first I am considering this rectangular portion, the big portion, and I'm taking as a A1. Okay, second I will deduct the circular portion, this I am taking as a A2. Next I will deduct this rectangular portion, and I am taking as a A3. So finally what will come? Finally it will come like this. Are you getting my point? Okay, so now I'm writing here A1. What would be the A1? So A1 is the area of rectangular section, or the dimension is given 600 into 350. So area would be 350 into 600. It will come around 21 mm square. It will come 21 mm square. Okay, now we can write here x1. So x1 is the centroid distance of this rectangular from the y-axis. So it will come 600, because for the rectangle centroid is h by 2 or b by 2, we can say 300 mm. Now we can write y1. So it will also come for the rectangle, y-axis is here. So it will also come for the y1, that is this one, and this length, that is 350 here. So it will be 350 divided by 2. So it will come 175 mm. Now come to this one, A2, that is circle. So we can write circle. Diameter is given for circle 150 mm. So area we can write pi by 4 into d square, that is 150 square. It will come 5625 pi. Okay, you can solve also. Now come to the x2. X2, see the y-axis is here. So x2 will be distance from here to this will be the x2, right? So what we can write? See, this centroid is here, and that is distance 150 from the right side. So we can write total distance is 600 mm. So it will come 600 minus 150. It will come 450 mm. Now y2. What will be the y2? So y2 is this centroid is here. So y2 will be from the x-axis. So this is placed at the center. This is placed at the center. So we can write total is 350. So center would be 350 divided by 2. It will come 175 mm. Now come to the for rectangle. So A3, what is that? This is the right angle triangle. So area would be 0.5 into or half into length into width or height, we can say. So half into what is the base width? 170. And what is the height? That is 160. So finally it will come 13600 mm square. Now see, this is also placed at the center. So 160 this one. So total is 350. So this total is 350 mm. So 160 this one. So what will be the value of this one? So this one we can write, and this one also. So this one we can write 350 minus 160 divided by 2. How it will come? So by solving, you can get like it would be 95. So here also 95. Now you can check also 95. This one is 95. So 95 plus 95. What is that? 190. And plus 160. It will come 350. It will come 350. Okay. So now we can calculate. So for the triangle, what will be the x3? What will be x3? So for the triangle, centroid would be somewhere here. So this distance we know that h by 3, or we can say b by 3. So b is here 170. So it would be 170 by 3. And this length is given 100. So from here to here, we can write x3, and that will come 100 plus 170 by 3. Now, so what will be the value? 156.67 mm. Now y3. Again, I have to erase. So suppose centroid is here. So we have to calculate this one. This one will be y3. So here this length is 95. This length is 95, and this length is also, we know that h by 3. It means 160 by 3. So finally y3 will come 95 plus 160 by 3. Finally it will come 148.33 mm. Okay, so now we have the A1, X1, Y1, A2, X2, Y2, A3, Y3, X3, right? So now we can apply the formula here. Now we can apply the formula here. So we can get the value of so we can calculate here the here the X bar. Okay, so X bar will be A1 X1 minus A2 X2 minus A3 X3 divided by A1 minus A2 minus A3, right? Okay, so all value we have. So I'm writing directly the value. So X bar will come, I have calculated, so I'm writing directly. X bar will come 296 mm, right? All data we have written already, y1, x1, x2. Now we can calculate y bar. So it will come a1, y1, a2, y2, a3, y3 divided by a1 minus a2 minus a3, right? All the data we have. So you can put the value, you can get the result. So I'm writing here 177 mm. Okay, so for we have to take the A1, we have to take the bigger section, larger section, and then you have to see A2 and A3. Then which area are missing, like what kind of hole are there? Like in the question, it is mentioned circular hole and triangular hole. So we have to calculate the area for that also, and then we have to find the X2, Y2, and X3, Y3 for them. Okay. Now, come to for this question. So in this case, a trapezoidal area are given, or in this trapezoidal area, a semicircle has cut from this larger section, that is trapezoidal section. So then we have to calculate the centroid. So first we have to assume some axis. So I am taking this is the y-axis, and this is I am taking the x-axis. So due to symmetry, because this semicircle has cut at the center of this trapezoidal figure, so we can say from this figure, we can say here due to symmetry about this line. Is it symmetry about this line? So we can say in this case x bar would be 300 divided by 2, that is 150 mm. Now we have to calculate y bar for this figure. So how we can calculate y bar? So I am going to take okay. So I am assuming this trapezoidal area as a A1. Then I will deduct this semicircle, that is A2. Then we will finally get this section, whatever is required. So we'll get this section by doing this. And we have to calculate y bar for this. Okay, so let's do it. So first we have to find out area, A1. Area trapezoidal section, that is height divided by 2. So 120 height is given, divided by 2 into summation of parallel side. So parallel side 200 plus 300. What area we can get? So we can get 4 times 0 mm square. Now, y1. What is y1? I have mentioned in the first lecture, there is a formula to form the base. If this is length is a1 and this length is b1 and this total height is h. So I mentioned a formula h by 3 into b plus 2a. Right? So this is the formula. So you can put the formula. So height is 120 by 3 into larger side. What is the dimension of larger parallel side? So that is 300. 300 plus 2 into 200, 2 into a plus 300 divided by 300 plus 200. What you can get? You can solve. We will get 56 mm. Now come to for the this semicircle. What is the area for the semicircle? So pi r square by 2. Pi into r is given, that is 90. This is r. So 90 square divided by 2. You will get, I've calculated, so I'm writing here. You will get 54005. Okay, now y bar. What is y2? So what is y2 in this case? So axis is same. Axis is same. You have to calculate from the x-axis. So this distance we know that is 4r by 3 pi. And r is given 90 mm. So it will come 4 into 90 divided by 3 into pi. It will come 38.1971 mm. Right. So now we have the a1, y1, a2, y2. So we can calculate y bar, that is a1, y1 minus a2, y2 divided by a1 minus a2. So now we have the a1, y1, a2, y2 put in this equation, and then you will get y bar, that is 69.11 mm. By putting all the value a1, y1, a2, y2, you will get this y bar, that is 69.11 mm. See, a solid consists of a cylinder of a hemisphere of equal radius. So this is the cylinder. Okay, and this is the hemisphere. Okay, of equal radius. So their radius are equal. Okay, fixed to base. Find the ratio of radius to height of cylinder. So suppose for the cylinder radius is r and total height is h. For example, h. Right. So we have to calculate ratio of radius to the height of cylinder. So r to the 8. This we have to calculate this ratio cylinder, so that solid has its center of gravity at the common face. In the question it is mentioned center of gravity is here. Center of gravity is here. For composite section, for combined solid bodies. So center of gravity is here. Okay. So if center of gravity is here, then we have to calculate this ratio. So this is the example of composite solid body. So in this case, we will apply the formula. Like I'm assuming this one as a A1 and this one I'm assuming A2. Okay, we have to assume some axis also. So I am taking this y-axis, and from this x-axis. So due to symmetry about this line, center of gravity will lie here. So now, so how we'll get this value? I'm writing here. Okay, now, so for the for hemisphere, what will be the A? That is area. So area for the hemisphere 2 pi RQ divided by 3. So in this case 2 pi RQ divided by 3 area. Now what is y1? See, for the hemisphere we know that their center for this one G1 we can write for this hemisphere, the centroid will lie up to 3 by r distance from the base of this hemisphere. But now in this case y1 will be distance from here up to the x-axis. So up to here it is 3r by 8, and this is total is h. So what it will come? So it will come h plus 3r by 8, right? H plus 3r by 8. Okay, so now we have the y1. Now come for this cylinder. Cylinder, what will be the A2? Sorry, in this, just correct. This is V1 volume. This is V1. This is solid body. So it will be V1. V1, Y1 is correct, and this will be the V2. If these are in the mm, so it will be mm3. It will be mm. Okay, so now I'm going to calculate V2. Okay, so volume for the cylinder, that is pi r square into h. So here the radius r and total height of cylinder is h. So it will be pi square h. Right? Okay, now come for this y2. So for the cylinder, centroid would be here. I'm writing G2. So this G2 will be h by 2 distance from the x-axis. So it's h divided by 2. Now we have this V1, Y1, V2, Y2. Okay. Okay. Now, so we can calculate y bar, that is V1, Y1 plus V2, Y2 divided by V1 plus V2. Because now I'm working for the composite section. But see, y bar for this section is mentioned in this question. In the question, it is mentioned the center of gravity is at common face is here. It means for this composite section that the y bar is given, and y bar is this distance. So what will be the y bar? That will be h. So in this question, it is mentioned then y bar is h. So we can write y bar is h. Now just put the value of v1, y1, v2, y2. So 2 pi rq divided by 3 into y1 h plus 3r by 8 plus v2 pi r square h into h by 2 divided by 2 pi r q 3 plus pi r q h. Okay, so wait, I need another figure. Okay. Okay. So now we can write, we can multiply, and then we can get here. So I am writing by multiplying. So I'm multiplying this denominator by h. So we'll get 2 pi r cube h divided by 3 plus pi r square h square, right? It's equal to, I'm writing this one first. So pi r square h square divided by 2 plus, by multiplying h by this one, so we'll get 2 pi r cube h divided by 3. Now I'm multiplying this one, so that we will get 3 will cancel, so we can write pi by 4 r to the power 4. 3 would cancel, so pi by 4 r to the power 4. So what we can get here, and in this case, okay, so by simplifying the next page, I'm simplifying this one. Okay, let me do it here only. So next step I'm writing here. So what would come? I'm writing here only. Okay. Next step is here. Okay. So that is see pi r square h square pi r square h square by 2. So it will be simply, and this we can write, this will be cancel out. Okay. So finally it will come pi r square h square divided by 2 is equal to pi r to the power 4 divided by 4. Now here you will see pi would be cancelled. 2 is equal to 2. R square will be cancelled. R square. So finally it is coming h square is equal to r square by 2. What we are getting? We are getting h square is equal to r square divided by 2. And we can write r square divided by h square, it will be 2. Or we can write r divided by 8 by taking a root on the both side. So we can write 2. On the ratio we can write root 2 ratio 1. So this is the finally why we are getting. This question, one thing was important. In this question it is mentioned that radius for both the hemisphere and cylinder are same, and center of gravity is lying at the common face. It means center of gravity is given. Y bar is given for h. That is h. Okay. So this two relation you have to keep in mind, and then you can solve this question. Now, a right circular cylinder is cut from the right circular cone. So what will be the center of gravity for the remaining figure? So this is look like triangle, but this is right circular cone. Okay. So data you can write here. Total height is given 600. Total height is given 600. So I'm writing here. Total height of right circular cone, there is 600 mm. Their diameter is given, that is 300 mm. Height of cylinder is given 300 mm. And radius, diameter of cylinder is given 100 mm. Now this data we have, and this one more thing is important. this right cylindrical circular cylinder is cut at the center only, from the center. So I'm taking one axis, y-axis and x-axis. So you can assume anywhere, okay? So that result will be different, but location will be same. If you will locate from the coordinate system, so that will be changed, but you will see on this according to this figure, so that would be same. So this I am taking y-axis, this horizontal is x-axis. So how we can calculate? Again, we will take the whole part, we'll select as a whole part, and then for second we select as a right circular cylinder, which is get cut from this right circular cone. Okay, so about this line, you can say this figure is symmetric. So by knowing this figure, by seeing this figure, we can write x bar would be 300 divided by 2, 150 mm. Because up to at a axis where the x is equal to 150 mm, so there about that line, this figure is symmetric. Okay. Now, so in this case, we have to calculate y bar for remaining figure. So what I can do? First, we will select a V1 as a right circular cone. Then we will deduct a cylinder. I'm assuming V2. This is cylinder. Then finally, we will get this remaining figure. So for this right circular cone V1. What is volume for right circular cone? That is 1/3 into pi by 4 into d square. What is the dimension here? Diameter here 300 square into total height, that is given 600. So what it will come? By solving, you will get this value will come 1,413,7166.94 mm3. Okay, and what will be the y1? So for this right circular cone, what we know? So center of gravity is h by 4. If total is h, so this is h by 4 from the base. So h by 4, total height is 600, divided by 4, it will come 150 mm. Now come for the cylinder. V2 for cylinder, pi by 4 introduced into h. So pi by 4, what is the diameter for the cylinder? That is 100. Pi by 4 to d square into length. What is the height of this cylinder? That is given 300. So by solving, you will get 235,6194.49 mm3. 235,6194.49. And what is the y2? So for this centroid for the cylinder would be here. So it is h by 2 distance. So 300 divided by 2, it will come 150 mm. So h by 2 again. So 300 divided by 2 will come 150 mm. So now we have the y2, we have the v2, we have the y1, we have the v1. So we can apply the formula that we have. Y bar is equal to v1 y1 minus v2 y2 divided by v1 minus v2. You can check what data we are getting. So v1 we have, I have written here. Y1 we have written here. V2 we have written here. And y2 also 150 mm. So by putting this all the value in this equation, you will get y bar. So I'm writing 150 mm. You can see, like, see, in the case of y1 was 150, y2 was 150. So y bar also we are getting 150. So why we are getting, I will explain here. We are writing formula like y bar v1 y1 minus v2 y2 divided by v1 minus v2. Okay, suppose in this case where the y1 is equal to y2 equal to y, for example. So put the value of y1 into y minus v2 into y divided by v1 minus v2. So by taking y common, it's coming v1 minus v2 divided by v1 minus v2 equal to y. So in this case, y bar, where y is equal to y bar will be equal to y, or we can say it is equal to y1 is equal to y2. So in this case, you will say y bar is equal to y is equal to y1 y2. So whenever you will see, suppose we have there are three sections are there. In the case of combined also, in the case of missing part also, you will see when their centroid are the same, so we'll get the same centroid for the combined figure also. In the case of whole also, missing part also, in the case of combined also. Okay, so this is very important when you are when some tricky question was given. Okay, so no need to solve a lot of data, because once you know this concept, so without solving this concept, once you know that y1 is coming 150, y2 is coming 150, so you can say for this combined figure y bar will also become 150. Okay, these are some reference that I have taken to make this lecture. Thank you. In the next lecture, I will start moment of inertia.